Okay. Uh, so, last class I am just discussing about the solubility studies. Okay. Students? Okay. So, now pK determination. So, what is pK determination? So, pK is the dissociation constant of a drug. Okay. So, it is the dissociation constant of a drug substance, and unionized, it is not ionized, unionized drug is mainly liquid soluble, that is formulates through lipid membrane. Okay. So, so the ionized substance is that is lipid insoluble, therefore formation is slow. Those drugs have a lipid soluble, that means ionized drug is a lipid soluble. So it can easily pass through the lipid membrane. Sorry. So, but in case of hmm, resolution,
একো শুনা পোৱা নাই।
It's not audible.
so
Sir, your voice is very slow, sir.
now is it audible to you, students? Is it audible to you?
Yes, sir, quite audible.
তাৰপিছত আৱাজটো একবাৰে লাহে লাহে আহে।
স্যাৰ কেতিয়াবা ভালকে আহে, কেতিয়াবা মাজে মাজে লাহে।
I have already changed my headphone also. Wait, I have to check. So now is it audible?
Yes, sir.
Yes, sir.
Clearly audible?
Yes, sir.
Yes, sir.
Yes or no?
sir. Yes, sir.
So now I am discussing about the pKa determination. Okay. So so what is pKa value? It is the dissociation constant of a drug. Right? pKa means it is the dissociation constant of a drug. Now is it audible to you?
Yes,
Is
sir.
it audible to you now?
Yes, sir.
Yes, sir.
Students, is it audible to you?
Yes, sir.
Audible. Yes, sir.
Not audible.
No, sir.
Okay. I just continuing. Okay. So so those drugs which is unionized drug, this is lipid soluble. Okay. So those are lipid soluble. They can easily pass through the lipid membrane. Okay. Ionized, those drugs are ionized. Okay. So these are not lipid soluble. These are lipid insoluble. Therefore, the permeation in the lipid membrane is low. Okay. So the degree of ionization is depends on the pH of that particular substance. Right. So Henderson-Hasselbalch equation, from the Henderson-Hasselbalch equation, that is pH is equals to pK plus ionized drag divided by ionized. Okay, so this is the equation for basic compounds. And for the acidic compounds, that is pH is equals to pKa plus unionized divided by ionized. Okay. So that is the percentage of ionized drug is 10 to the power pH minus pKa divided by 1 plus 10 to the power pH minus pKa. So this is the basic equation for the basic and acidic drug. So that means in terms of, that is unionized drugs are lipid soluble, so it can easily permeate in the lipid membrane. But ionized drugs are lipid insoluble. That's why the permeation in the lipid membrane is become very slow. Okay. So what is the determination? How can we determine the pKa in terms of analytical method? So in terms of analytical method, we can determine the pKa by UV visible spectrophotometer. Okay, then potentiometric partition and that is trimetric method. Okay, so these are the main analytical techniques. So students, have you got the notes in your ERP? Have you got the notes in ERP?
তাতে নোটছ
Yes,
বিলাক
sir.
চাইছিলো স্যাৰ, তাতে নোটছ বিলাক স্যাৰ চিষ্টেমেটিক দিয়া নাই স্যাৰ। স্যাৰ তাতকে স্যাৰ আপুনি যোনবিলাক শ্লাইড
Students, are
পঢ়াই
you
স্যাৰ
there?
সেইবিলাক সেইকেইটা শ্লাইড
Students, have you got the notes in ERP?
য়েছ স্যাৰ। স্যাৰ তাতে পাইছিলো নোটছ বিলাক,
Samsud, am I
কিন্তু স্যাৰ
audible
তাতে
to you?
নোটছ বিলাক স্যাৰ য়েছ স্যাৰ
Samsud Jaman?
য়েছ স্যাৰ 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 মই
Hmm?
স্যাৰ শুনি আছো স্যাৰ।
Uh, so,
স্যাৰ তাতে স্যাৰ নোটছ বিলাক স্যাৰ ERP নোটছ বিলাক চাইছিলো স্যাৰ, তাতে স্যাৰ নোটছ বিলাক স্যাৰ পঢ়ি পেলাই ইমান এটা ভাল নালাগে স্যাৰ। স্যাৰ বস্তুবিলাক মানে চিষ্টেমেটিক দিয়া নাই, ত' সেইটো কাৰণে স্যাৰ আপুনি যোনবিলাক শ্লাইড মানে পঢ়াই স্যাৰ সেইকেইটা শ্লাইড যদি স্যাৰ আমাক যদি শ্বেয়াৰ কৰি দিয়ে তেতিয়া আমাৰ
share
কাৰণে
কৰি
সহজ হ'ব স্যাৰ।
তোমালোকক share কৰি মই গোটেইখিনি বুজাই লওঁ, টপিকটো যেতিয়া বুজাই শেষ কৰিম তেতিয়া মই তোমালোকক slide share কৰিম। ঠিক আছে? নে এতিয়া লাগিব
ঠিক আছে, থেংক ইউ স্যাৰ।
শ্লাইড এতিয়া লাগিব নেকি তোমাক?
স্যাৰ দিলে ভাল হ'ল, ভালে আছিলে স্যাৰ।
ঠিক আছে, অ'কে, মই চাওঁ বাৰু যদি মই পাৰোঁ পাৰ্ট বাই পাৰ্ট মই তোমালোকক যিটো ক্লাছৰ হ'ব সেইটো ক্লাছৰ মই শ্লাইডখিনি শ্বেয়াৰ কৰিম। ঠিক আছে, আজি এটা ক্লাছ হ'ল,
ঠিক আছে, থেংক ইউ স্যাৰ।
শ্লাইডখিনি মই আজি শ্বেয়াৰ কৰিম, কাৰণ গোটেইখিনি শ্লাইড শ্বেয়াৰ কৰিলে তোমালোকে বস্তুটো চিষ্টেমেটিকলি নুবুজিব। বুজিছানে?
অ'কে স্যাৰ। অ'কে স্যাৰ।
So next come with the solubilization. So solubilization is defined as the spontaneous passage of purely water soluble solid molecules into an aqueous solution of a soap or detergent in which a thermodynamically stable solution is found. So what is solubilization? So that it is the process of spontaneous passages of purely water soluble solid molecules, okay, in an aqueous solution, not an non-aqueous solution. It is only used in the aqueous solution, okay, of a soap or detergent in which thermodynamically stable solution is found. Okay, so this is called as a solubilization. So solubilization is the process by which apparent solubility of an otherwise springly soluble substance is increased by presence of surfactant micelles. That means, what is the procedure for solubilization? So those are poorly soluble. Poorly soluble means, what do you mean by poorly soluble? What do you understand by poorly soluble?
They do not solubilize very easily.
Yes. Means
They,
they are very difficult to solubilize. Got it. So how can we increase the property of solubilization of these compounds? Okay, with the help of surfactant micelles. Have you seen what is the properties of soap? What is the properties of soap? How it is works?
So it solubilizes the non-polar particles in
Exactly.
water.
Yeah, it is. And it increases the solubility of the particle. That is, those who have adhere as a dust, okay, in the particular surface, it will directly, that means, increase the solubility of the particular substance with the help of becoming a foaming agent, right? Creating the foams. The foams are creating some micelles that will absorb the particular what? Dust. It's nothing. So it is called as a surfactant. Surfactant are used to increase the what? What? Increase the solubility. Then what is micelles? So the mechanism involved is the property of surface active agents to form colloidal aggregates. Okay, so surface active agents are converted into colloidal aggregates, is known as micelles. Okay, so when surfactants are added into the liquid at low concentration, then they tend to orient at the air liquid interface. On further addition of surfactant, the interface becomes completely occupied and excess molecules are forced into the bulk of the liquid. Okay? And last, a variety high concentration of surfactant molecules in the bulk of the liquid began to form micelles, and this concentration is known as critical micellar concentration. What is that? First, when surfactants are added in a liquid at low concentration, they tend to orient at the air liquid interface. Okay, they will just air liquid interface with the, it means it is the upper portion of the upper surface of the what? Upper surface of the solvent or in the liquid portion. They will just stuck on the upper portion of the liquid portion solvent. Understood? When we are further adding the surfactants, so the interface becomes completely occupied and excess molecules are forced into the bulk of the liquid. The upper portion, the upper interface are completely occupied, then excessive amounts of the surfactants are goes into the bulk of the liquid. Okay. So a variety of high concentration surfactant molecules in the bulk of the liquid began. Okay, a variety of high concentration surfactant molecules. That means excessive amount of surfactant molecules into bulk liquid, into bulk solvent to form micelles. Okay, the concentration of the surfactant in the solvent is known as what? Critical micellar concentration. So it is called as a CMC. Okay, so how can we increase the solubility? Okay, how can we increase the solubility of a substance? Okay, so by adding the course, micelles are the substance that increase the solubility. It's not it. Micelles are the substance that increase the solubility. Like example, that is surfactant. Is not it? It can increase the solubility of the dust particles in a polar or non-polar. Okay. So addition of cool solvent. Second method is pH change method. Then reduction of particle size. Then temperature changing method. Then hygrotrophy, addition of surfactant, dielectrical constant, and complexation. So these are the main methods. That is, how many methods? 8 methods are there to increase the solubility. Why it is required? Solubility. Why solubility is important in the preformulation study? What is the relation of the solubility in preformulation? Can you tell me someone?
Sir,
For drug stability, sir.
For drugs? For drugs
For the stability of
stability. Yes, Ambrose, can you repeat it again?
I said for drug stability, sir.
Stability. Not,
Yes, sir.
not only stability. Solubility is required not for the stability. Stability also, but not, it is not only the, it is correct, but it is not only the stability. Anyone?
absorption of drug,
Who?
extent of absorption of drug,
Absorption of drug.
and gives idea about doses from.
Idea about doses form. That means to give the proper bioavailability. Is not it? If the drug is not soluble in our suitable media, you know why dissolution test is required? Why? Dissolution test. What is the importance of dissolution? Have you heard dissolution previously? Have you heard the dissolution test?
Yes, sir.
Yes, sir.
Yes. Yes or no?
Sir.
Yes, sir.
Yes, sir.
What do you mean by dissolution?
It rate of dissolution. Gives us information of rate of dissolution of drug
Hmm?
in body.
Voice is not clear. Please speak loudly.
It can gives us information of rate of dissolution of drug in body.
Asmita, please speak loudly.
Sir, it can gives us information of rate of dissolution of the of drug in body.
Hmm. Yes. In a suitable media. In a suitable media. Okay. In a suitable media, it will give us the proper dissolution of the drug. In a suitable media in our body. So, I'm again telling you, I have already discussed, if you are using mouth dissolving technique, what is the pH of our buccal cavity?
Your voice is again becoming hazy, sir.
What is the pH of the buccal cavity?
Sir, can you repeat the question again?
What is the pH of
Your
the
voice is
buccal,
hazy.
what is the pH of the buccal cavity? What is the pH of the buccal cavity?
Sir, nearly
Sir,
neutral, I guess.
sir, in between
Yes,
6.2 to 7.6.
Sir, nearly
yes,
neutral, sir. Sir, nearly neutral, I guess.
Sir,
Sir,
it should be
it will be
alkaline.
pH
no,
of the
sir.
buccal cavity?
It's not.
Sir, in between 6.2 to 7.6.
No, no. Yes, Sri.
Sir,
What do you mean by buccal cavity?
hello? Sir, nearly
Sir, nearly neutral, sir, up to 7.3, I guess. 6 point something to up 7.3, sir. 7.6 or 7.3, sir. Sir, ভালকে মনত নাই কিন্তু নিউট্ৰেলৰ নিয়াৰলি নিউট্ৰেল হয় স্যাৰ আৰু মানে 7.6 মান হয় আপ টু
No, no. Yes or no? If you don't know that, tell us the answer. I don't know.
স্যার বুজি পোৱা নাই স্যার শুনা পোৱা নাই
Let's say, is it audible to you?
স্যার বহুত কম
Not
এতিয়া
very
শুনি
clear.
পাইছো বাট
Yes.
নট ক্লিয়াৰ একদম ক্লিয়াৰ নহয় স্যাৰ
Yes or no?
স্যার একদম ক্লিয়াৰ নহয় কেতিয়াবা শুনি পাওঁ কেতিয়াবা নাপাওঁ স্যাৰ
একো শুনা পোৱা নাই?
এতিয়া পাইছো কেতিয়াবা নাপাওঁ স্যাৰ
Hello? শুনিছানে তোমালোকে?
শুনিছো স্যাৰ এতিয়া
শুনিছা?
শুনিছো
Sir, আপুনি যেতিয়া সোধে শুনিছানে বুলি তেতিয়া ক্লিয়াৰ থাকে স্যাৰ
এতিয়া ক্লিয়াৰ আহিছে?
এতিয়া ক্লিয়াৰ আছে স্যাৰ
So what is in the buccal cavity?
বাকী
অসমীয়াত ক'ব গ'লে স্যাৰ
মুখৰ কম
মুখৰ portionটো নহয় জানো?
অসমীয়াত স্যাৰ
Yes,
Yes,
sir.
sir.
Okay. So what is the pH of the buccal cavity?
Slightly acidic.
Sir, slightly alkaline, no?
Alkaline, yes. It is alkaline. So see, when we are going for solubility, why solubility is required important?
Sir, solubility, sir, low solubility, sir, leads to poor absorption
Exactly.
of drugs, sir.
Exactly. So solubility is important when we are using the particular drug. Okay, when we are using particular drug, we are targeted to dissolve it, disintegrate it or dissolve it. Okay. If it is in acidic pH, just 1 minute. Okay. If it is acidic pH, then it will dissolve in acid. Okay. Then we have to check the solubility that that particular drug substance is soluble in that particular acid. Okay. If we are targeting that particular drug in, just wait. Hello. Change. क्या बोलना कुछ तो अपन नेक्स्ट दुटा बजे पर असेल एग्जाम yes so I'm just talking about the solubility. Why solubility is important? Mainly thing is that solubility, if we are when we are going to target the drug, okay, it is very important that it should be disintegrated properly in that particular drug, a particular suitable medium. It should be very easily to disintegrate and easily to soluble in the particular that means media. Otherwise, it cannot be absorbed. It cannot be permeate. It cannot be absorbed. It cannot be metabolized, or it cannot go through the systemic circulation. Understood? Understood?
Yes, sir.
So this is the main method. These are the 8 methods that is involved in the increasing the solubility. Okay. So we have to modify. See, we have to modify all the formulations. If we are going their properties only, we cannot prepare a drug. If you are saying that paracetamol or you are saying that acetylphenol is not soluble in water or any solvent, we have to increase the solubility that it should become soluble. That is called the solubility enhancement. Okay, by forming the micelles that we can increase the solubility. Okay, so why we are using that? Why we have to calculate the critical micelle concentration to get the frequency of the solubility. Okay, how much that particular drugs and particular substance are soluble, you can get from the critical mycelial concentration. Okay. So next is the partition coefficient. Uh, what do you mean by lipophilicity and hydrophilicity? Hydrophilic and lipophilic.
Sir, hydrophilic is water loving and lipophilic is lipid loving.
Exactly. Lipophilic is lipid loving. That means it is lipid soluble, and hydrophilic is water soluble.
Water soluble.
So maximum our membranes are mainly not. That means these are all lipophilic, prepared by lipids. Okay. That means drug those where it is absorbed, the membranes are mainly lipids. Okay, that is air. That's why what we have to do a measurement of drug lipophilicity. If drug is soluble in lipid, okay, then it is easily what? Easily absorbed in our body. Understood? To cross the cell membrane, our cell membranes are mainly what? Prepared by lipids. Okay, our cell membranes are prepared by lipids. If the drug have the tendency to lipid soluble, then it is easily what? Permeate or easily cross. Getting my point? Yes or no?
Yes, sir.
Yes, sir.
Yes. See,
Yes, sir.
drugs are lipid soluble. Those drugs are highly lipid soluble, then it easily permeates because the permeation, that means membrane is prepared by what? Lipids in our cells.
They can easily cross the membrane.
Easily covers the membrane. Okay, so that's why solubility is important. If drugs are mainly lipid soluble, then we easily cross the membrane. So partition coefficient is that is the calculation. Rho O by A is equals to C organic divided by C vectors. So by this calculation, we can, that means, calculate the partition coefficient. What is partition coefficient? It is a measurement of drug lipophilicity. Okay. If the drug is highly lipid soluble, then it can easily cross the cell membrane. That is the main one. Okay. So distribution coefficient. So distribution coefficient, these are the formula for acids. That is log n D, log P. Okay, I will discuss properly on this. What is distribution coefficient? This is the that means introduction class of the year. That means preformulation. It is another sector. Okay, partition coefficient, distribution coefficient. It should be discussed clearly in the next class, in upcoming classes. Okay, you just check that for acids, what is the formula? This is one the formula, and for basic, this is the formula for distribution coefficient. Okay, so this is octanol water system. Okay, so for the calculation of the distribution coefficient, octanol water system is the phenomenon that is used for the calculation of the distribution coefficient. Okay, so for the buccal membrane, buccal cavity, butanol pentanol system is used for the distribution coefficient system, and blood-brain barrier, for the blood-brain barrier, that is chloroform and cyclohexane system is used for the calculation of distribution coefficient. Okay, and it is determined by Shake-Flax method. Okay. Shake-Flax method. What is Shake-Flax method? I will discuss later on. Okay. So this is the main. That means importance of the solubility. These are the, that means partition coefficient, distribution coefficient. These are main terms under the solubility. Okay. So okay, Shake-Flax method is already that means I have already given. So what we have to do in Shake-Flax method? So drug is shaken between octanol and water. So we have to take octanol and water. Okay. So we have to place the drug in octanol water and we have to shake. Okay. So we have to take the sample. After shaking, we have to take the sample and analyze for the drug. Okay. So one rule of 5 is there for a drug permits to the passive diffusion. Okay. So log P is the greater than, if log P is the greater than 5, then drug can pass with the help of passive diffusion. So what is diffusion method? What do you mean by the diffusion method? What do you mean by diffusion method?
So this passes from higher to lower concentration.
Exactly. Passive diffusion means if it is in higher concentration, then it is directly flow to the lower concentration. Okay. So example, if uh, uh, example is all of you 60 students are kept in a small room, very small room. You are just, you have no any other surface area to stand properly. Okay, you were just kept in a small room, or you were kept in a bus. That means the capacity of the bus is, if it is 30, you are placed 60 people in that particular bus. When your destiny is arrived, when the doors open of the bus, you will just come out. Is not it? তোমালোকে ওলাই আহিবা নাই বাছৰ পৰা? যেতিয়া তোমালোকে ডেষ্টিনিখন পাবা, পোৱাৰ লগে লগে তোমালোকে বাছৰ পৰা কি কৰিবা? Just come out from the bus. Why? Because the concentration of in the bus, the concentration of the students is much more higher. তোমালোক কি কৰিবা? তোমালোকে লোৱাৰ কনচেন্ট্ৰেশ্যন ওলাই আহিবা, তোমালোকে ফ্ৰী স্পেচ, you just want a free space where, okay, now I am in free space, now I am in comfort. Is not it? Is not it?
Yes, sir.
Okay. So this is called the from higher concentration to lower concentration. If you are sitting in a AC room, if your door is open, then the cold air is come to the in the outside. Why? Cold air is come into the outside, or hot air is come into the inside. When you are open the AC room, of all the doors and windows are open, the room is not cold properly. Why? Because higher concentration, the hot air is in higher concentration, the hot air comes into the your room and it will never become in a cold position. It's not it. It never allows to become cold the particular room, because the from higher concentration the hot air is coming into the cold room, that particular AC. Understood? So there is diffusion. Diffusion means it is passes from the higher concentration to the lower concentration. So there is a rule of 5. Okay. If log P is greater than 5, then it is the passive diffusion. It follows a passive diffusion. The molecular weight of the particular drug is below 500 mg, then it will follow the rule of 5. That is, it is goes to the passive diffusion. Through the passive diffusion, it will cross the what? Lipid membrane. It will cross the lipid membrane. That when we are taking the drug, it will disintegrate. After disintegration, it will goes to the permeation, metabolism, then permeation, permeation to the cell membrane. If it is not permeate the cell membrane, it cannot go with the systemic circulation. That means it cannot contact with the blood. Okay, it cannot contact with the blood. So, so these some rules are there. Okay, so the next rule is there are more than 5 hydrogen bond donors. If the drug have 5 hydrogen bond donors, then it will follow the passive diffusion. Okay, there are more than 10 hydrogen bond acceptors. That means number of hydrogen plus oxygen. If the particular drug, the structure of the drug, particular molecule have the particular structure of 10 hydrogen bond acceptors, then it will follow the passive diffusion. Okay. And again, the molar refractivity. Molar refractivity is between, if it is between 40 to 130, then it will follow the passive diffusion. So in passive diffusion, we need not require any external forces to permeate the particular drug into the systemic circulation. It will follow the passive diffusion. Passive diffusion means in the outermost of the cell, the drug content is higher, then it will pass easily through the lower concentration, that means to the cell. It will insert the cell. It will enter the cell with the help of, that means by crossing the lipid membrane. Okay. So this is the rule of 5. So next come with the dissolution. Okay. So what do you mean by dissolution and why it is required? What do you mean by dissolution and why it is required? So খুলবে নেকি তোমালোকে? কারো রেসপন্স নাই যে? Is it, am I audible to you now?
Yes, sir. Audible.
Yes. তোমালোক টোপনি গুচি গলা নেকি? কথাবোৰ বুজি পাইছেনে?
Fine.
পাইছে? Okay. So dissolution মানে কি কোৱা? আকৌ কৈছো, what do you mean by dissolution? Why dissolution is important? See, in our body we have different concentration of our pH.
Good.
Okay. In our buccal cavity, the pH is different. In our stomach, our pH is different. In our intestine, our pH is different. For the targeting in the intestine, what type of formulation we are just preparing for tablet? We are preparing the enteric coated tablets. Okay, we are preparing the enteric coated tablets. What is the enteric coated tablets? They are dissolved in the, they are disintegrated in the where they are disintegrated.
Can you repeat the question again?
Where the enteric coated tablets are become disintegrated. Where the enteric coated tablets are become disintegrated. Where? Don't know.
Intestine.
Yes, very good. So what is dissolution? We are just preparing one media in the outside as our, that means pH of our internal body. Okay, as our internal body pH, we are just preparing one. What? We are just preparing one same, that means environment. If it will dissolve in the, we are taking the that means non-dissolution tablet, that means those who are dissolving not, then we are taking the different pH as a media. We are মানে মুখত যেটো in buccal cavity, it will dissolve in buccal cavity, then we are taking the same media as similar to our buccal cavity. There is alkaline pH. We just put the drug in that particular pH and we can check the, that means absorption of the particular drug. It will dissolve properly or not. It will that means mix with the particular alkali media or not. We have to check. Then we can conclude that yes, it will be dissolved in our body. Understood my point? Same condition.
Sure.
We are taking the same alkali media in our intestine. Why we are using enteric coated? Because it will pass through our stomach. What is the pH of the stomach? It will acidic.
Acidic.
That means in acid, if you are put something in acid, it will directly disintegrate. Is not it?
Yes, sir.
So we have to make some, that means we have to make some coating on that it will not dissolve, it will not disintegrate in our that means our stomach in acidic pH. It will safely pass through the acidic pH, then it will disintegrate in the where? Understood?
Yes, sir.
So dissolution, that is we have to check, we are just preparing same environment as it is in our body, in the outside. we can check the solubility, we can check the rate of dissolution of the particular drug in our body. Okay. So see, you can see solid drug in the GI fluid. GI fluid means gastrointestinal fluid. Okay. So rate constant of dissolution KD is called as a KD. Then drug in solution of the GI fluid, rate constant of the absorption, then drug in systemic circulation. So dissolution in this dissolution process, these are we can calculate these things, that is solid drug in the GI fluid, rate constant of the dissolution, then drug in the solution in the GI fluid, rate constant of the absorption, and drug in the systemic circulation. When that means rate constant of absorption is greater than rate constant of dissolution, then dissolution is significantly slower and the absorption described as dissolution rate limited. That means if the rate constant of absorption is greater than the rate constant of dissolution, that means rate constant of dissolution is very much slower than the rate constant of absorption, then we can conclude that dissolution is very slow. The rate of dissolution is very slow. Okay. The dissolution rate of drug substances in whose surface area is constant, the drug dissolution described by this equation. Okay, that is the equation. By this equation, we can calculate the dissolution rate. So dc by dt means dissolution rate. H is the diffusion layer thickness. Diffusion layer thickness means the layer of the particular membrane, lipid membrane of cell. Okay. C is the solute concentration in the bulk solution. Solute concentration means the amount of drug present in the amount of drug with the excipients present in the particular solvent. V is the volume of distribution in the medium. D is the diffusion coefficient, and A is the surface area of dissolving solid, and CS is the solute concentration of the diffusion. So this is the calculation by this is the formula. By this formula, we can calculate the dissolution rate of dissolution. Okay. So students, today up to this, I think you are a little bit benefited. If you have confusion, next class you just ask me, I will describe it. Do you have confusion?
No, sir.
Yes or no?
No, sir.
Yes. Okay. In the next class, I will just clear your confusion. Okay. Fine.
Yes, sir.
All of you are giving your attendance.
Yes, sir.
So fine. Next class. See, if you are absent in your class, if you are not able to attend the class, if that means any critical reason, don't give the silly excuses. If you are not really attend the class in some critical condition, then you can just inform me, sir, I will not attend the class. Give me the message. Fine? Fine? Okay.
Okay, sir.
Okay, sir. Okay, then. Thank you. You can leave
Thank you,
now.
sir.
Okay.